Okay, welcome to Nerdy Nawg-dawg, and today we are talking about surface area. This should be a review at this point. So what we have here is a triangular prism, meaning that two of the sides are the same and they have a triangle surrounded by three rectangular sides. So to really solve for this, it's got all the different measurements, and these are all in centimeters. But to really solve for this in terms of area, I want you to think of this as if I needed to wrap this shape with wrapping paper, how much wrapping paper would I need? I'm not looking at how much stuffing would be needed to fill in this shape. I'm talking about how much does the outside shape take up when it is unfolded. So in this case, I would need to draw a net. And that is the easiest way to really detail the different parts. And I'm going to start by taking this inside rectangle as my main base. So I've got one rectangle here. I know that if I were to unfold this rectangle, it would be a shape like such. And another rectangular shape like this. And then if I folded down this triangle and the opposing triangle, it would be something like this. Okay, exacting is not necessary. Definitely not necessary. What we really need to do is identify the area of each shape when it's unfolded, the two-dimensional area. We know that the formula for area is length times width. So now we need to identify the value of each. So if we're looking at this inside rectangle here, and I'm going to go ahead and color that in. So I'm looking at this rectangular shape here. I can see that my length is going to be 10 and my width would be 8. So inside my net, I'm going to write 10 times 8, right? Length times width. And I'll go ahead and solve when I have it all worked out. Now, I also know that if I move to this rectangle here, I can see that the width is 8, and it looks like the length is 13. So I'm going to do 8 times 13 on this one. And if I were to unfold this one on this side, I see that it does have a length here of 13, but where do I find the width? The width would either have to be this up here or right here. And that 12 doesn't match there, but I can assume that if this width is 8, then this width is also 8. So I'm going to call this length 13 by 8 and write that in here. Okay. Now for the triangles. I know the formula of a triangle to solve for area of a triangle. It can be considered as base times height divided by 2, or half of the base times height. And so here is my triangle. Let's see if I can grab a different color to really accentuate this triangle. So here's my triangle. And as you see, they gave us a measurement of this 12 down a dotted line from the top. That instantly tells me that this is going to be my opposing vertex. Do you agree? You should agree. And if I come down from my opposing vertex, I am able to make a right angle there. So I know automatically this is my base. So in measuring the triangle, I need my base. In this case, it's going to be 10. The height, they put the measurement in the middle there. That was at 12. So 10 times 12 divided by 2. So I instantly know that's 120 divided by 2 gives me 60. And then I can write in that each of these triangles is 60. So then my last step for solving for surface area is to then add all of this together. And I can just make a little space there. So I've got, 13 times 8, which is 104. I've got another 13 times 8, 104. Or I can just add those, 208. plus my 2 triangles, which would give me 120. And then in the middle, I have the 10 times 8, 80. And now I have accounted for all of those portions there, and I can add them up together. And I should have 408. Now remember, I said this was centimeters. And because this is a 2-dimensional shape that I am unfolding and solving for area, it gets a squared. Okay? 408 centimeters squared. And that is how you solve for surface area.